jealous. All right, so here we are. We got our general factoring, and what we're going to take a look at, and this is, I guess, as we title it, 6.4c. We're going to try to see what you know here. Overarching principle. We talked about this yesterday. All right, our overarching principle is whenever we start a factoring problem, what are we always going to look for? Okay, we're always going to look for a GCF, okay, a greatest common factor. So that is going to be just an overarching thing that we're always going to be trying to focus on no matter what. It would be like me saying, you know, hey, when you get this as an answer, 4 over 2, do I need to say simplify? No. So our overarching thing is always look for a GCF, always look for a GCF. When you start the problem, it'll make things easier. It'll make things more straightforward. Second, if there's not a GCF, then we start looking at possible scenarios. It might have 2 terms, okay? And if it has 2 terms, something that we look for would be the difference of 2 squares. All right, so example there would be a squared minus b squared, which would factor, as you know, to a plus b or a minus b. Another example might be 9x squared minus 49. What perfect square is 9? What times what? 3x, right? So 3x plus 7, 3x minus 7. But this is always going to have a pattern of something squared minus something else squared. So that's the difference of 2 squares. You're going to see them some of the time. When you do, you grab them and you take it and you go from there. Now, I'm going to put this in red and I'm going to call it A2. The sum of 2 squares. Do you remember what I wrote on the board yesterday about the sum of 2 squares? The sum of 2 squares would be something that would be like a squared plus b squared. And this does not factor. All right? Hence why it's written in red. So the sum of 2 squares doesn't factor. You just don't go any further. Does that make sense? The difference of 2 squares you roll with, the sum of 2 squares you can't do anything with. All right, the next thing we were going to look for that might have 2 terms that we just dealt with is either the sum or difference of cubes. So let's review our little formulas. A cubed plus b cubed. Do you remember our thing? San Diego Padres, same sign, different sign, positive. So let's do a little review here. What's my first binomial? Okay, it's the same sign, so a plus b. And then a squared, and here's the different sign, remember? Minus ab, and then the same positive plus b squared. So there's the sum. And then let's do the difference one. A cubed minus b cubed. Who thinks they can give me that whole thing? Jonah?
So a minus b.
A minus b.
A squared plus ab plus b squared.
Okay. So same sign, different sign, positive. Aaron?
In the homework, in some problems, like when you would square the a squared, and then you have to still write it out, like they would still have it squared.
Sometimes it's just trying to help you see that what it is.
Because then it looks like your answer that you squared, like you have to keep squaring.
Right. Okay. Well, it's just a different way of writing it sometimes. I think if you work it out, you're fine.
Okay.
You're fine there. All right. Third scenario. we've got three terms. In other words, we've got a trinomial. And with the trinomial, you just have to, and I know this sounds strange, but work it out. You know, the first thing we're going to do, I guess in step one, would be to put our parentheses. The second thing we would do is figure out our signs. You know, are they plus plus, are they plus minus, or are they minus minus, you know, that kind of thing in terms of our parentheses. We would look at the first term and say, hey, what are the factors of the first term? So the first term factors. We look at the last term factors. And one of the keys for when you have a trinomial is first making sure you take out a GCF, right? Because if you take out a GCF first, I guess we can put a little note here. No GCFs in the binomials, because we've already taken them out originally, which should help us with our deduction of those problems. So, and then last, we've got four terms. And when we have four terms, we're going to use a process called grouping. That takes you all the way back to Algebra 1. And when you're grouping, your steps would go something like this. We would group them together, maybe with a trinomial and a single number, or maybe the first two terms and the last two terms. And so when you're grouping them like that, you're going to look for a common factor on both terms or on both pairs. And then once you've done that, then you might look for another common factor again, just as some steps. And grouping is going to be a very rare occasion that works, but it might happen sometimes. And I just want to let you know it's kind of there as a possibility. We're going to talk about that more, maybe just to review that a little bit tomorrow or even Friday. So that's kind of what I would say would be our summary.